In this video, let's focus on stoichiometry reaction. Most of them will find this question very interesting. But then, let's have it. We have it as 0.25 mole of hydrogen chloride was dissolved in distilled water and the volume made up to 0.5 dm cube. If 15 cm cube of the solution requires 12.5 cm cube of aqueous sodium thiocarbonate for neutralization, calculate the concentration of the alkaline solution. So we're given the options. Now, trust me, if you could solve this, please, you can comment your answer in the comment section. Let us see whether you know it or you can do it, okay? So please, feel free to comment your answer in the comment section. But then, we have it that 0.25 mole of ACl, hydrogen chloride, was dissolved in distilled water. So let's see if I should draw a diagram. If I have in this container, I have distilled water, H2O, and then HCl was dissolved into it. So you have hydrochloric acid of 0.25 mole, okay, was dissolved into the water, thereby making the hydrochloric acid solution. Okay, now after putting in the HCl into the water, you have the volume to make up 0.5 dm cube. So the volume then make up 0.5 dm cube. Now this dm cube, right, to convert it back to centimeter cube, the volume is then equal to 500 centimeter cube. Now you might be wondering how do we convert from dm cube to cm cube? Now 1 dm cube is equal to 1000 cm cube. So 0.5 times 1000 is what? 500 cm cube. Good. With this done, if 15 cm cube of the solution requires 12.5 cm cube of aqueous sodium thiocarbonate for neutralization, now this means that, okay, let's say out of 500 cm cube of this hydrochloric acid, we took out 15 cm cube, right, this amount of volume from this solution. Okay, now we put it inside this container. We took out 15 cm cube of HCl. The volume is about 15 cm cube, okay, and then we pour it into the container, which also contain about 12.5 cm cube of sodium thiocarbonate 4. So sodium thiocarbonate 4, okay, was also in the solution, but the volume is about 12.5 cm cube. Now with this, HCl reacts with Na2CO3 to undergo this neutralization reaction. Okay, good. So once you've done this, the next thing is to, okay, write down the balanced chemical reaction, which is you're having HCl. HCl is reacting with sodium thiocarbonate 4. Now, if HCl reacts with Na2CO3, what will be the product? The product will be NaCl, then plus carbon dioxide, and then water. Okay, so with this, let's then balance the chemical reaction. We have one hydrogen here, we have two hydrogen here. So if you put two here, you have two chlorine, you have one chlorine. So if you put two here, you have two sodium, two chlorine, then you have one carbon, three oxygen, you have 2 plus 1, 3 oxygen. So the equation is balanced. Now, once you are to solve a reaction that has to do with acid and base, okay, acid, HCl, and base, Na2CO3, okay, just be in mind that you will apply this given formula, which is given by CaVa over CbVb is equal to Na over Mb. Now, don't be confused. Let me explain this term one by one. Now, Ca is the concentration of the acid, Va is the volume of the acid, Cb is the concentration of the alkaline solution or the basic solution, Vb is the volume of the base, Na is the number of mole of the acid, Nb is the number of mole of the base. And the number of mole of the acid and the number of mole of the base can be gotten from the balanced chemical reaction. Okay, so the question is that calculate the concentration of the alkaline solution, which is the concentration of the base. In other words, or to calculate the value of Cb, because Cb is simply the concentration of the base or the alkaline solution. Okay, good. Now to solve for Cb, okay, examine your equation. Do we have Ca? Do we have Va? Do you have Vb? Do you have Na and Mb? Now, okay, let me clean up this space. Let's then clean up space. Good. Then Ca, the concentration of the acid, was not given to us in the question, was it? No. So write down question mark. The volume of the acid that reacted with the base is 15 cm cube, right? So it's equal to 15 cm cube. The concentration of the base is what we're asked to find, the of the alkaline solution. So Cb is equal to question mark. The volume of the base is equal to, so the volume of the base directly with the acid is 12.5 cm cube, so equals to 12.5 cm cube. The number of mole of the acid Na can be gotten from the balanced chemical reaction. So this is the acid right here, HCl. The number of mole is what? 2. So 2. The number of mole of the base is 1 right here. So writing down 1. Then the goal is to now calculate the concentration of the alkaline solution or the basic solution. This right here. But notice something. We have an issue. The issue is that we don't know the concentration of the acidic solution, in which once we get the value, we can put into the formula to then solve for Cb. Now, how do we calculate the concentration of the acid? We can solve that using, okay, but then let me clean up this place. To then solve for the concentration of the acid, we will apply the formula which is given by N is equal to C times V. Okay, where N is the number of mole, C is the concentration, and V is the volume. Okay, so to now solve for C is then equal to N over V. Is it not so? So C now is what we're looking for. The number of mole of the acid is 0.25 mole of hydrogen chloride. So writing down 0.25 over the volume of the acid, right, is the volume of the acid is the volume of the HCl when you pour it inside the water, which made up 0.5 dm cube. Is it not so? Good. So write down the volume is 0.5 dm cube. Now if you divide 0.25 over 0.5, you will get 0.5. So therefore the conc of the acid is equal to 0.5 mole per dm cube. Okay, good. Now since you have gotten the concentration of the acid, let them input the value of Ca into the formula VaCbCb equals to Na over Nb to then solve for what? The concentration of the base or the alkaline solution. Can we do it? Yes, good. So if I clean up this place, the value of Ca is 0.5 mole per dm cube. So writing down 0.5 times the value of the volume of the acid is 15 centimeter cube. Now notice something. You have it as centimeter cube. Convert the cm cube to dm cube by dividing by 1000. So times in brackets 15 over 1000. Okay, that will be in dm cube over the value of the concentration of the base is what you have to look for. So Cb times the volume of the base Vb is 12.5 cm cube. So convert this cm cube also to dm cube by dividing by what? 1000. So 12.5 over 1000 is equal to the number of mole of the acid is 2. So 2 over 1. With this, let us then simplify. So 0.5 times 15 over 1000, 0.5 times 15 over 1000 is simply 0.015 over Cb times 12.5 over 1000 is 0.0125, okay, is equal to 2 over 1. To then solve for the conc of the base, simply multiply so that you have 0.5 times 0.015. Now, if 0.5 times 0.015 multiply 1, you have it as 0.5 times 0.015 is equal to 2 multiply this, 2 times Cb times 0.0125. Now, to then solve for Cb, okay, divide both sides by 2 times 0.0125. So 2 will divide this over 2 times 0.0125. Then 0.0125 will divide 0.0125. You are left with Cb. So Cb is then equal to 0.5 times 0.0125 is 0.0075 over 2 times 0.0125 is 0.025. So CB is then equal to, if you divide 0.075 over 0.025, you get 0.3. Now, the unit of the concentration is in mole per dm cube or molar. So with this now, what is the correct answer? Option A, 0.3 mole per dm cube. I hope you've learned how to calculate stoichiometry. Please, if you enjoyed the video, please don't forget to like the video, share the video to your friend, comment in the comment section your answer, and also please don't forget to like and follow and subscribe. Thank you very much. See you in the next video.